Okay, so last class, we started practicing how to select out of a data frame using either indexing or selecting columns by their name. And so this is along this thread of this week that we're trying to, how do we subset? And then today we're going to transition a little bit into how do we summarize our data, right? So get data out, how do we make summary? Because let's face it, we all want to find the means of things. We want to group them by different types of variables. And so that's what we're going to practice today. So the exercise that you're going to have assigned to you at today, that'll be due, will kind of incorporate the selecting elements as well as the summarizing elements from today. Okay. All right. New script. Set my working directory. Do. So have you guys been able to download that tiny fish data set? And whoever's got that on, you can turn it off, that'd be amazing. I don't have a God complex yet, but that would definitely help. All right, so let's go ahead and load in our tiny fish data set. So this is an R data file, so it already has an object name assigned to it. And we don't have to load a library to read it in. It's part of the base R package. Bless you. Okay, let me fix this so I can see all my panes here. There we go. All right, what does this look like? So this is actual data from a paper that I published last year in Science Advances. I can show you, it's from the Straits of Florida. What we were doing is we were running transects with an underwater camera. So each transect had a name. The ostrich, it was, you know how scientists love to come up with like cool nicknames for their projects? So they came up with ostrich. So that's why it's OST. Happened in 2014. This is the transect name. We had 3 depths, shallow, mid, and deep. So SMD. We were looking to understand, we were trying to identify discrete patches of different types of plankton. And so right now we just have larval fish here, or any other types of plankton. So I identified like discrete patches, and then they were given ID. And the camera runs along behind the boat. So there, we identify the patches by a timestamp. So this is when each patch started. And then there's also a distance element, right? Because you're running along the earth lat long. This is a lat long. This is the distance to the next patch. And then this is how many fish per cubic meter are in a patch, in a parcel, excuse me, parcel. And then this is how long it is in meters. And then we have different types of parcels. So patches were the most intense. And then we have random ones and things like that. So if, for example, you ran the function unique p type, you should see, I believe, at least 3 different options come up. Okay. All right. So this is a little bit more interesting than the taxa data that we were working with on Tuesday, because we're going to work on like how to group by things and summarize. Okay. So the first thing that I want to do is I do not want to be writing tiny fish all the time. It's just a little long. So I'm going to just reassign the data in tidyverse to a new object. Well, we're just going to call it D. There you go. All right. I'm reassigning to a shorter object name because I am lazy and don't want to write that out. All right, so let's warm ourselves up and try to pull some skills from last class. Let's see here. So I just asked you guys to check what type of parcels were available for us. And you guys probably do this too. You're like, what the heck is this, right? Y'all make up names for your data, right? Like when you're coding, like shorthand. Okay, well, I'll explain this. So it always looks crazy. Is NIP stands for not in patch. And then there was a threshold. Not in patch, different type of threshold, and then zeros is there was no fish. Okay. All right, so we want to pull out all the rows that have patch as the parcel type. So let's go ahead and do that. All right, so I want to assign this to a new object. We'll call it P. What would be my first move here? What's the syntax? Heard it whispered, perhaps. Do I need to identify the data frame I'm working with? Yes, thank you. All right. You're very close. Okay, that's part of it. $. Go down to this. Okay. That's okay. This is a condition, right? So it's like a true false. So we want to pull out everything where P type is equal to a condition. What condition is that? Patch. Yeah. All right. So we are missing something important here. Brackets. Thank you. The other part is we have to identify what data frame we're working with up front here. Now, the last thing I need to do is add a comma. Good job. All right, so we check unique, P type, and we should only get patch, and we do. Good job. What if I wanted to select all the observations that were not P type patch? Well, we have a very similar looking thing, but there'd be one difference. I was going to copy this because it is extremely similar, but what would I change? Yeah. So what does not equals look like? Yes, good job. Exclamation point. Good job. Okay. I want to select only
the first, second, and fifth columns using indexing. So like this. Okay. I'm going to assign this to a new object. We'll call this. Good job. Okay. How are we feeling about this method of selecting things? Okay. All right. So the last one we're going to practice before we move on to summarizing is using the column names. So let me bring this back up here. There we go. If you forget the names of your columns, because there's a lot, you can use the names function, which is what I'm going to do here. So those are all the column names in our data frame D. And let's grab transect, parcel ID, and P density. So we're going to do this by the name. We're going to select the columns, transect, parcel ID, and P density by name. Okay. All right, you guys are working on that. I'm going to walk around.
What we're doing is like takes a while. Okay, anyone have trouble with that? All right, hold up. Yeah. You must have that problem too. Okay, so that tiny finish. You gotta load it. Yeah, it's not just that you have to load it as a file. To load it and then try running one file.
Okay. So here's a way you can do this. I'm just going to copy these guys. Take out my and because that is not valid. And an extra set of quotations. Why are you not? Do. Transact parcel line. Oh, there you go. All right. You sure could, but I asked you to do it by name. Yeah. I always get worried, and this is maybe my paranoia, about using indexing because I'm worried about miscounting. And it's not intuitive for me. I don't know innately what number 1 is, column, or if you've got like 15 of them, what 11 is. And so I always feel better when I'm really trying to make sure that everything is robust by calling things by their name. So it is more typing, but I feel more comfortable with it. But if you've got your brain wired where you're cool with it, you know, doing it by indexing is not wrong. So another way we can do this, and I looked this up because I didn't do it very well last class, is using this operator called in. And it looks like this. Operators always will have the percent sign as part of their notation. So if you may remember from our first exercise where you guys had challenge questions, and I asked you to do inner and outer multiplication, you may have found on Stack Overflow an operator for inner and outer, and they had the percent signs. Okay. So why would we want to do this like this? Well, later on, we're going to get to a point where we may be needing to repeat an operation multiple times, and we don't want to be writing out the column names over and over and over again, right? This kind of gets a little bit long. So this is kind of thinking towards setting an object name once and its values, and then being able to reuse it later on. So I'm going to make an object name, I think, trying to remember, what names do I have? Yeah. So it should look, I'm going to scroll it for you. Did you set your working directory? Where the file is at? Yes, I know that, but like what files do you have in the working directory? Right, they should be right there. Any questions on that? See it in your environment. And then the problem is that there's an underscore method here. So I'm just going to copy this for now. And I don't want to type it out. I'm just going to call this, I don't think I have an object called n. I do not. Okay, so I'm assigning these three values, character values, to an object n. And now, call this D4. Still using our brackets. We're going to say D. Get this together. We can just do it like this. Okay. Yeah. All right. All right. We use n for rows. Okay, I'm gonna get this together. All right. So here's a shorthand, so we don't have to type that out all the time. All right. So this is not the right header. This is using object values. Sorry about that. All right, so we're gonna pull out all the patches, parcel types, and all the zeros. So I'm just gonna set Z to be a value of patch and zeros. Okay. So the syntax here is D P type. Now, last class, we learned that if we wanted to select by condition, we would have to write it out like this. So it'd be like this equals patch, right? And then we would use an or we would say D P type equals 0. Okay. If I check my work, Y P type should only have patch and zeros now, and that is true. But writing this out can be a little bit kind of laborsome. So we've already defined, bring this back down here. We've already defined Z to be those two things. So we'll try this instead. Still D parcel type. And now we're going to use this in operator in Z. Let's see if we get the same result. Did I not define it? Sure didn't. Let's try it again. All right, let's see what happened. Patch and zeros. All right, let's pause here for a second. So this is like being really explicit and like writing it out, get along. But like if you're trying to replicate this a bunch of times, you don't want to write this out all the time. Whew. And so you can just set the values once, as we've done in Z, and then we can just say, pull out all the rows from P type and data frame D that match those values in object Z. You guys follow that? Okay. Okay. We're going to switch gears and talk about grouping things and summarizing them now. Does anyone have any questions about how we select things or subset? grouping by conditions and summarizing. So my go-to set of functions for these tasks are in the tidyverse package. It has sub packages that do these things. So if you haven't loaded tidyverse yet, go ahead and we'll do that. Okay, so often we're going to want to find, like, let's say in this case, we're going to try to find the mean length of all those different patch types on our tiny fish data set. So we should end up with a data frame that has 4 rows, one for each one of those types, and that has the mean length. So the first, there's 2 parts to this task. One is telling R to group things, and then telling R to summarize. So we're going to use something called group by. There are a lot of different varieties of this. This first one is my default. So, all right. So the data that we want to group by is in data frame D. And then we need to tell it what thing we want it to group. In this case, we want to group by P type. Now, a different little thing about tidyverse that is different from base R is that you may remember that when we've been working with column names, you always have quotations around that text. Hadley, who develops tidyverse, I think he hates quotations for some reason, because for his functions, when you identify the data frame, you do not need to have quotations around the column. Like this. So I just ran this, and we're going to just pull up the first few rows here. Okay. So it looks very much like that Tibble thing we did where we were reading like an Excel file. But one difference here is that it's identified that there are different groups. So I can type. You want to summarize? So you can use the summarize function. And here, the input, what are we summarizing? We're going to summarize our data in the object, the grouped data. And then this is kind of an open, it's like an open framework for adding the different types of summarizing metrics that you're interested in. And so in this case, we're interested in finding the mean. So we're going to use that mean function. Now, it wants us to assign, you can't assign a name to basically, because you're going to get a new data frame out of this. So whatever the value is going to go, the mean value is going to go in a column. So we can assign a name to it. So we'll just say mean, and I think we just said we're going to do distance, I believe. Yes, we are. Mean length. So that's mean. And then here we're going to type in a column that we're actually going to be taking the mean values of. So in this case, it's going to be that, I believe, P length. See, I forget my, there we go, P length M. All right. So everyone get to this point? Okay, let's run it. What happens? Oh, I overwrote it. Fail. I need to do this. Okay, I'm going to rerun it. Rerun this, and then rerun this because I overwrote it. Okay, did what we asked. Woo! So we have a data frame, a new data frame that's under the object grouped data summary, GDS. And we have our 4 different parcel types, and we have the mean length associated with each one of those. Don't freak out that like the trailing decimals are not here. I did that when I first started using this package. I was like, where are they? They're there. Okay. So here is a tip too. Sometimes, so in our data frame, we do not have any NAs, right? NAs are a placeholder for missing data. So R will get fussy if you try to run summarize functions like standard deviation or mean on data that has NAs in it. I'll be like, it'll give you an NA as a return, and that doesn't make any sense. So if you have NAs in your data, you can set an argument here, and I'll show you in a minute, to exclude those NAs so that it works properly. Looks like this. All right, buddy. I knew you're in here. I know you're in here. It's NA remove true. Ooh, I see how it is. What's going on? Oh, what is this? This? Nope. NA, I think it's NA remove equals true. So we can also have additional metrics in our summarize function. It's not a one-stop shop. You can like start having a grocery store list of things that you want to create. So I'm just going to go ahead and here and copy this. We're going to add a few different additional metrics to show that. Let's try N, the sample size. What else would be a good one? We'll do the variance. Okay. All right. So we're just going to be repeating this part for the additional 3 different functions here, or is it 4? 1, 2, yeah, 3. Okay. So I'll do standard length, standard deviation length, and it's SD. Don't stress that you don't know these offhand. It's just, you can always, that's why you have Stack Overflow open or whatever. You can always look them up, or you can ask for help in R. The variance is varying, var, so it'd be var length. And then the last one we'll do is sample size. And that, so this one is different. This is one weirdo. This one you just leave blank. You just leave it empty. Okay. So we're asking R now to return a summary table that has the mean, standard deviation, the variance, and how many observations went into each one of those calculations. I'm going to call this summary 2. All right. Okay. How are we doing with this? Did everyone get this answer? Cool. All right. So we can actually combine our group by and summarize functions in one line and connect them with an operator. And it looks like this. So the way that we write this out is almost identical when we were doing it line by line. So I'm just going to do that right now. So we're using group by. This is what it mostly, okay. So the first part of this call is we need to tell it what data frame we're pulling from. We're pulling from D. And what this, we're going to use this operator twice in this call. And this operator is defined as, let me write this down, I should have done that earlier. It's defined as pass to. It's essentially like a connector. It says take whatever's on the left side of it and pass that information to the function on the right side of it. So we're going to add this operator right here. Take the information in D and pass it to the function group by. So unlike when we use group by itself, I no longer need to identify the input data. It's already been passed to it from that operator. I just need to tell it what things we're grouping by. In this case, we'll keep using p type. That column p type. Okay. So now we've grouped our things and we want to pass that grouping on to our summarize function. So we need to add and use that operator once more. And this looks identical to what we were doing before. I'm not going to do the other ones. Okay.
Beat the dead horse. This object is going to be a summarize of just the group, the means of the four ones we had before. But we're doing this in one call. So take the information in data frame D, pass it to our group by function, group by person type. So we have 4 person types. Take that grouping information and pass it to summarize and do the work. All right, let's run it and see what happens. Woo! Okay. I'm going to give you guys a couple exercises to do here so that I'm not just yapping at you. Summarize. Summarize. Spelling is important. Nope, that is not how you spell summarize. Find the me. Ooh, my spelling has just dropped off here. Let me try this. It's a little bit more exclusive. Okay, go forth and conquer. Yeah, it's on this. That's okay. So what's There you go. See? Okay. So just have to make sure that this is matches that column. Right? So we got yeah, that's what's called. Try that. Yes, the- okay, so you're not really so input is to density part. Summarize. It will look. Does it look like it's supposed to look? Yeah, that's how you know if you're okay. Yeah, that looks, oh, yep. Yeah, so just check. How's everyone doing? Y'all finished?
Second here. Turn off my Wi-Fi. It's not helpful. All right, so I'm gonna write this out. So we have a record of what it's supposed to look like. So we'll call this E summary. Whoa, calm down. Really, Windows? No. Yeah, that's great. So now now the university's gonna think that I'm trying to get you guys to watch wrestling. So a few of you had some issues with it not working. And the first place to look is just to make sure that you're writing out the column name exactly as it is. The computer is not going to be like, oh, you really meant this. It is very like robotic, obviously, because it's a computer. So that's my always first check when I have something that, did I misspell something? Did I forget an underscore or a dash? This is also why, for that reason, that I aim to keep my column names fairly simple, and I do not mix upper and lowercase letters, because inevitably I will forget which letter is supposed to be uppercase. Or I'll be like, oh, it's supposed to be, I don't know. It just annoys me. So I just try to simplify my life up front and not have like crazy column names. So. There we go. And then we'll do the next one. You do not have to use the operator if you don't feel comfortable doing that. I didn't do this for a long time, so I wanted some people like to do it step by step. Both of those methods I showed you are completely valid ways to achieve these tasks, or to achieve, you know, the goals of these tasks. Always check. Okay. Okay. So another summary function that I use a lot is summary. It's not summarise, it is summary. And I use this because sometimes I want to know what the range of the values are in my data frame. It's going to show me if there are any NA values in any columns. It's a really nice shorthand way to just get familiar with what the data looks like. So usually when I import data, I'm going to pull up the first 6 rows, what you've been doing to death. So I understand what the column names look like. Everything looks like it's imported fine. And then my next usually step is to do the summary function to see what the data looks like, NAs, as I just said before. So what does that look? So how do we do that? All right. To understand the, like the structure / of the values in your data set, use the summary function. Okay, so I just ran summary D. And so our transector characters, so it's not so present here, right? But like for all our numeric things and even our time columns, it's able to provide just like the, basically like quantiles. So we see our min time, our max time, we see everything like that. I'm going to scroll down a second. We don't have any NAs in this data set. If there were NA values in any of these columns, they would be, it would say it down here and say like 13 NAs or something like that. Okay. We can do this for just a single column. Okay. All right. This gets useful later, particularly if you're trying to understand, if you're trying to set like the max and min for a graph or something like that. Sometimes you want to kind of understand, and this is getting into the distribution of your data. We can use a call to understand the, like here, the default for these quantiles is like the 0, 25, 50, 75, and 100 min max, right? But maybe we want to get more granular. If you want to know the you can do this for whatever. Like, let's say we want to know the distribution of the data for every, what does that look like? Quantile. D, we'll do length again. And then we have to use this argument called probs. That stands for probability. Do you remember what we could use when we were trying to create a series of numbers that were together, but we wanted to set the interval? We used this function called sequence. Yeah, we're going to use that here. So the probs can only have a max value of 1. It's basically 0 to 100%. So we're going to alternate the interval. That's what we're changing here. So from 0 to 1. And then the by here is going to be 0.1 because I said I wanted to be every 10. Okay. So we're just getting a little bit more granular with like the distribution of our data. So what does this mean? Okay, so 10% of the data, 29% of the data is in the lower 10%. 54% of the data is in the lower 20%. I mean, these are the cutoff values. Okay, my bad. All right, so values 29 or less are in the last 10%. Values 54 or less are in the lower 20%. And then of course, as you go up, this would be like a max value, right? So everything's less than 8,661. Trying to find this function. I wanted to show y'all. There we go. I knew it was a thing. Yes. Okay. Right. All right. The last thing I want to show you is how to create like a really verbose summary table of all your stuff. To do this, we need to actually install a new package called vtable. Let me do that up here. I think I did this. Hey, that's not what I wanted. Okay. Library v table. Now we have access to those functions. Okay. So this function is shorthand. It's called sum table, but they just shortened to ST. So we will see what happens. We're going to do ST, and then our data frame is just D. So let's go. Try this. What? Oh, thank you. There it is. I appreciate you. So you can export this if you wanted. To copy it. I'm going to copy it to a clipboard. And let's say I'm going to open up a Word document here. See your advisor like wanted summary statistics on something. Hey, that's not what I wanted. Let's try this again. Export, save as an image. I'm going to say sum table. Save. Okay, let's try this again. Insert picture, this device. Let me go back to my Word document here. Share. Well, that is anticlimactic for sure. Why isn't this working the way that I want it to? Okay. I have to be able to export this. This is not complicated. I'm going to get this. All right. All right. So this is the best way to do it. This is in, let's try this. Nope. So I'm just printing this to a PDF so you can get it out of R. Okay. All right, we are at time. Does anyone have any questions? We got a couple minutes before we end about summarizing stuff and grouping things today. Okay. Well, look for that exercise. I will try to send a message out to let you know when it's posted. And I am grading your exercises. I've in the history I've had a past of not being great about giving quick feedback. I'm trying my best to be much better about that. So. Last thing, remember, we have a guest lecture next Tuesday, the 13th. It's River. You guys are gonna be going over if else statements.